Sorry, everybody, I'm having a little. Really appreciate you guys taking the time to join us today and have a little chat about how we can complement firewalls. Now, one of the things I like to promise is, as we described in the invitation, is this webinar will be short. My objective is to finish this within about 10 minutes max. Then afterwards, open it up for questions. Let's keep it productive. Webinars, and I am a victim of that too, can be long, boring, and not so much fun. So I'm going to try to keep it lively as well. So that being said, today we're going to talk about the firewall market space and what's missing, what can we do to improve that kind of product category as a whole. So we're going to look at Elfiq Link Balancers as one of the remedies, or one of the, not remedy, my apologies, one of the add-on, one of the value props you can bring to a network to enhance it. I'm going to give you a quick 30-second crash course to Elfiq networks as well, and afterwards open it up for questions. So firewalls, and I'm going to take a very agnostic, brand-neutral position here. Firewalls all fundamentally do the same thing. It doesn't matter if you look at them as a firewall or a UTM, or where you want to brand it in that space. But fundamentals of the firewall, and I'm not going to teach anybody here anything. It's perimeter security. It's intrusion prevention. It's VPN connection management for mobile users or site-to-site connections. It's content hygiene once you fall into the UTM space with antivirus, anti-spam, content filtering, URL filtering, and so on. You can apply some security policies, and some even there go into the idea of using multiple ISPs as an extra feature in that mix. So firewalls, nothing new here. This is what they do. This is where they're really good at. What's missing is that a firewall or UTM is fundamentally a network telecom piece of equipment, and we're talking about telecom. 10 years ago was a very different landscape where internet connectivity was very useful, but for most organizations was not as critical as it should be. So we want to help the firewall keep its services running. So what firewalls are missing to actually deliver this value prop is that it's not able to run multiple ISPs efficiently. Firewalls do not support the ability of inbound traffic. So a common example for that is mobile VPN clients. If your ISP goes down, you're typically down completely, and your mobile users, which can be your sales force entering orders, can be penalized and not being able to enter and doing that. Or you have a customer-facing app on a website hosted on-premise. Customers won't be able to go in and access the value prop. VPNs, from a site-to-site perspective, have always been something that is a bit of a sensible thing from a connectivity perspective. If one of the two sites loses connectivity, both sides are penalized. And looking at BCDRP as well, I mean, what's missing in this equation? And I'm going fast here on purpose and by design because I promise I'll make it go quick. So link balancers. What's a link balancer? The goal of a link balancer is to complement your existing infrastructure. We're not looking with those kind of products to replace your security infrastructure. We want to bring redundancy for internet access for inbound and outbound traffic. So those devices will be sitting on your network between your existing carrier and your firewall. So those devices will go out and take the traffic coming from the firewall and actually send it to the most appropriate ISP at a certain point in time. And the opposite is actually quite possible. So if I've got a user, which is my yellow dot here, and he's trying to access my on-premise services, that user can actually come in through any of the carrier links based on policies, saturation, availability, the usual style metrics. But suddenly all those services that are getting protected by that perimeter security now have an extra layer of availability. And this becomes really interesting for any organization because internet access is like electricity. You can't work without it. It's pretty much that simple in this day and age. So this is what a link balancer looks like and where it sits. From a business point of view, link balancers will let you and enable your users, your online services, etc., to capitalize on internet access. I mean, this is another way of looking at what's happening in your network. Um, these are simple examples of what's happening on your networks today. And if those services or those users don't get connected to the internet or online services or cloud applications, whatever it may be, there's usually a financial impact associated to it. So that was just an alternative, non-technical way of looking at it. So typically, when we talk to organizations about complementing a firewall project into having a multiple ISP redundancy scenario, the first thing that comes to mind is how much damage you're going to do to my network if you bring such a device into an existing network. So the way the Elfiq product is designed, it's an inline layer 2 transparent device. It feels like a switch or an IPS on the network. So you don't reconfigure your firewall. You don't duplicate your rules. You don't go into a complete puzzle. And from a visual perspective, your firewall thinks it's going to be talking to the original primary link or the ISP that was there before the project, and in reality, it's going to be talking to the link balancer and juggling, and the link balancer will be juggling multiple connections concurrently. The firewall is oblivious to this type of activity, and a link balancer product like Elfiq is interesting because it's firewall agnostic. It doesn't matter which brand of device you have. You may have an open source device you built yourself, like you went and got a big brand name. It really doesn't matter. Now, because we're in a security-conscious topic, one of the things that we get asked a lot is, all right, you just dropped a piece of networking equipment into the public zone. Help me here understand how this is not going to bring my network down, because let's face it, we're beyond the security perimeter. Because the Elfiq device is a layer 2 inline device, it's transparent to the internet. Or another way of saying it, the WAN ports of the link balancer are MAC address driven. It will balance on layer 3-4 parameters like source IP, destination IP, and so on. But from a visibility perspective, the Elfiq Link Balancers don't have an IP address for the WAN ports, physical or virtual. So traditional attacks cannot be accomplished on the device, and we actually let the security perimeter device do its job and not pretend to be a security device. So this is something that's really interesting and important. From a benefit perspective, failover. I mean, like I said, internet is the same thing as electricity. No electricity, no business. No internet, no business. So we bring that failover capability that's missing in most brands out there. Outbound traffic balancing. This becomes fun because your users are getting more bandwidth based on what you have deployed. Inbound traffic balancing and failover, I'm going to put those two in the same bucket. That's your external users, your roaming users, your customers, your outside services, etc. And you can deploy any ISP. It doesn't really matter what kind of technology you can find in your part of the world. We have customers that are in metro areas and can get a buffet selection of services, and we have customers that are not so lucky, and sometimes they use 3 or 4 DSLs because that's what's at the plant in location X. And the fun part is we, in this process, eliminate the need for BGP. BGP is very useful. It's the protocol that runs the internet, so it has its place. But from an SMB or even a large organization perspective, going through the route of a link balancer, you eliminate the need of an AS number, negotiating with the carriers, having BGP compliant gear, and so forth. It's there, it's working, it's quick, and you can use pretty much anything you can get your hands on, down to USB 3G keys that you can pick up at a retail outlet. So your options are becoming very interesting. Now, that being said, VPNs are a topic close to my heart because VPNs are the lifeblood, as usual, of most businesses with multiple sites. In a traditional VPN environment, you've got the scenario where if the head office or the branch office has a carrier failure or their carrier links are saturated, you're stuck. Now, in the concept of link balancers, we have the ability to multiplex traffic that is being passed between two sites? Should we have a link balancer at each site? So what's really important here in this slide is that orange line I'm going to use as an example, where what's happening here, this is an example of a 2-on-2. From an ISP perspective, I could make it a 5-on-5, but it becomes a big, colorful mess from a slide perspective. So I'm going to avoid that by sticking on 2-on-2. But the interesting part is this here is here, and this here is here. So the traffic going in this direction and traffic going in this direction will have access to the fastest path available. So we can go from the top left to the bottom right and send the traffic back to the top right, back to the top left. And we can have that ability to go out and distribute traffic based on saturation and performance. Now, even more fun, this is the #1 reason why organizations buy into this concept, is that what if one of my guys, one of my ISPs disappear? What happens? Well, in this case, this traffic is not being reset. The session is not being reset. So if you got voice or VPN, you just lose this ISP here in yellow, and the traffic continues. We even have a video demonstration on the Elfiq website of this with pliers. Do not try this at home, of course. But in this scenario, I can actually take this guy, take it out of the equation, and we still have a working VPN between the two sites. So we bring that kind of ability to the table where you've got a firewall at each site. You've got those resilient, you want to bring some resiliency because, let's face it, you've got 50, 75, 100, 200, 300 people working at a branch office, connecting on the primary data center at the head office. You want that mass of people to be able to continue working normally. So that being said, I'm going to erase all that yellow and moving on. Sorry, wrong button. So quick crash course on who is Elfiq. I'm done with the firewall complement bit, and I hope I didn't go too fast, but that's why we have QA at the end. Elfiq's been around since 2003, selling products since 2004. We've got units deployed in 120 countries. We've won awards. We're friends with a whole bunch of people. Most importantly, we've sold to a lot of organizations, and I'm pretty sure you're going to be able to recognize 1 or 2 names in this slide deck. Sports fans, just look to the middle on the top, and these are our customers. We sell and service organizations around the world, regardless of their business vertical or their geography or their user size. The universal bottom line is we need the internet to work. Otherwise, all my perimeter investment is moot. So I promise to make it quick. I have made it quick. I'm opening up the floor for questions right now. Please do so using the question toolbox in the presentation tool that is on your screen. So any questions we can help with, please go ahead. I'll let you guys, give you guys a few seconds so you can type in your questions. I have a first question from Steve. Steve asks, this is cool and interesting, but you seem to integrate a point of failure. What happens if your device fails? Steve, thank you for the question. The reality is Elfiq is, and very proudly so, we have built the only product line in our product space that supports 2 philosophies of uptime for the equipment. First one is the traditional high availability cluster of a unit that will be handling the traffic, and a secondary unit in case the first one is not able to continue for whatever the reason may be, then traffic will be handled by the second unit. That is one way of doing it. And the unique part is the second part, where if we have a single unit and the unit loses power for whatever the reason, on every single model you have at least 1 pair of ports that will be able to fail to wire. So you have a non-powered Elfiq in your rack, but it's acting as a crossover cable. So you have the ability to bring that that uptime, even if you have a downed unit. You will troubleshoot it later, but your users are not penalized for having a unit without electricity in your rack. So, Steve, thanks for the question. Next question, how does this work for video conferencing? There's two ways, Trevor, I can answer your question based on two common scenario. If you have a user coming in from the outside, let's say a teleworker VPNing into the environment, that would be the first example. Let me actually get the slide out, and it's easier with visuals as usual. So if I use this example, this scenario, I've got the yellow dot here, which is my user. He's going to try to go in and video conference from whatever device he's got, a laptop with a webcam or whatever it may be, and the balancer is going to receive the request from one of the carrier links. And I'm going to avoid the complete DNS discussion for today, but it's really a DNS game that's happening. And the balancer is going to respond to the user, you need to come in through here because this one is letting you know is the most appropriate at this point in time. So we can select ISPs based on saturation, based on QoS rules, based on traffic allocations you want to do for specific applications, namely video conferencing is a common one. Now, that is scenario number one. Scenario number two, which is a site-to-site application, we fall into this scenario. So if I've got all those dots here are people in a conference room here at head office, and I've got 3 people or 4 people here at branch office. Normally, your video conference is going to hop onto the VPN. The VPN is going to get multiplex to use as much bandwidth as is available and guarantee uptime at the same time for from all the carriers that are there. So your branch office or your sideline office staff will benefit from more bandwidth, and should one carrier fail, then the video conference will continue because the VPN session will not get reset. So I hope I answered that question to your satisfaction. If not, do not hesitate. Ask another question. Next question, 3G or 4G compatibility currently from Daniel. If is it now or in the future? If yes, does it work? Do we need to install software for the provider? Is it possible? So here is the 3G aspect of the feature. There's 2 ways you can use 3G or 4G onto a link balancer. The first one is Ethernet modems. The second one is USB adapters. Now, both have pros and cons. The pros of the Ethernet modem is that we get, from an Elfiq perspective, we get an Ethernet handoff. So at the end of the day, it's treated as any other ISP link with a dynamic or static IP, depending on your carrier and the class of service you bought. So there's nothing to be done specifically to make anything work any different. From a USB perspective, the pro is it's available on pretty much any street corner. The con is, and there's a complete discussion on our 3G white paper, by the way. And this is me being picky on USB, but you can easily pull it out of the balancer. Of course, you need. I'm going to assume that you're not racking your equipment in a locked cabinet, but that's one problem. The other problem is antenna strength can be a problem if you, depending on where you put it in the building. And also, we have to build the driver in the firmware. So we have a list of the supported devices right now on elfiq.com/3G. You're going to be able to see which USB adapters the firmware supports. You need EOS 3.5 or greater if you're already a customer. And you can go in and put in a 3G key in your balancer, and this is a great lifeline in case everything else fails. Then you have that available to bring some support to the table. So hope I answered that question as well to your satisfaction. Any other questions? I'm going to keep the chat box open. Oh, there we go. We have another another question from Trevor. How effective does this work if a remote site has one ISP? Can multiple connection be used for the same ISP. So if you've got a satellite office that has only one ISP, that is going to be a bottleneck. So the product can only go as fast as the ISPs that you put in front of it. So can you put multiple ISPs from the same carrier? Absolutely. So when you, let's say you're in a situation where you can only get DSL and you need to augment bandwidth, then you simply buy more DSL lines. And I'm using this as a generic example, but we've got customers with 4 to 6 DSLs at one single office, and they're going to use the side path multiplexing to make this an artificial larger line. So if you've got, I'm going to use hypothetical numbers just for the sake of the math. Let's say your DSLs are 512K symmetrical, and you put 4, you're going to create yourself a virtual 2 megabit line, which suddenly becomes a heck of a lot more interesting than what you had before, and without necessarily attacking a lot of cost to that project. Because let's face it, DSL is very convenient and very affordable. And can we do this? Absolutely. So I hope I answered the question to your liking. Next question I've got is, how many ISPs can it handle? This question is easily answered by, it depends on the model. The model range goes from 2 ISPs to 320 ISPs. So the average that we see on a customer site is 3 to 5 ISPs in real life. Depending on where you are, what are your objectives. We've got customers that go up to 12 easily. So it depends on the model and the capacity you need for your organization. My recommendation is elfiq.com/model selector. It's the model selector is an online tool that will guide you through a few simple questions to the most appropriate model based on your specific situation. So I hope I answered that one too, to your liking. Any other questions?